Good morning, good morning. So today's video is going to be on similar figures, excuse me, and properties of similar figures. So I'm going to zoom out just a little bit so you can see the paper a little bit more. I provided you this paper in your agendas, so I want you to copy the paper exactly the way that it is in the agenda. If you can print it out, print it out. So you should have a sheet that looks like this. It says similar figures at the top. And then kind of towards the bottom it says properties of similar figures and finding a missing side in a similar figure. And then if you turn it over, then you have the inside, right? And we're going to go ahead and we're going to copy all this down. And then I'm going to go over on how to solve these problems. So again, we have this side that says similar figures, but then when you turn it over, it's going to be upside down. So make sure that you copy it upside down because we want to make sure that when we fold it, our foldable is going to look like this. It'll say similar figures at the bottom, and it'll say properties of similar figures and finding a missing side in a similar figure. So the paper that you start out with will look like this, and the other side again is going to be upside down. So if you need to, pause so that you can do that. Again, this is going to be in your agendas. So let's start off by talking about properties of similar figures. So there's two things that all similar figures must have in order for them to be similar. One, they have to have congruent corresponding angles. So I'm going to write that down for you. Congruent corresponding angles. And you'll see what I mean by that in just a moment. And two, the ratios of the corresponding sides must be proportional. And we've been talking about that concept for proportionality a lot lately. Our essential question for the day is going to be, how can proportional relationships be applied to geometry? Now you'll see that in the description here of the YouTube video. So if you need that for your Cornell notes, again, it's going to be how can proportional relationships be applied to geometry. So we're doing two things today. We're going to discuss the properties of similar figures, and we're going to find a missing side in a similar figure. So after you've copied all this down, your foldable's ready. When you open it up, it's going to open up to these figures right here. It says similar figures have the same shape but different size. So this is one property right here. Similar figures have the same shape but different size. Notice these two triangles are the same shape but they're different sides. We talked about they had to have congruent corresponding angles, which means we're going to call this triangle FGE, and we'll call this triangle JKH. So what we mean by congruent corresponding angles, angle F and angle J, they have to be congruent to each other, meaning they have to have the same measure. The word congruent means same. So those, I'm going to put one notch there to show that those two are congruent. And then again, angle G and angle K, notice how I'm putting two notches there to show that those two correspond. And then last but not least, angle E and angle H, I'm putting three notches there to show that those two angles correspond with each other. Now from there, this triangle gives us the length of side FG and the length of side FE. The smaller triangle JKH, they give us the side length of JH, but we're missing JK. So our task here is to figure out the length of JK. The trick that I like to do in order to figure out which sides of the triangles correspond, I like to draw the smaller shape inside of the larger shape. So I'm going to go ahead and draw it in there. I'm going to label the angles J, K, and H, and then I'm going to fill in what we know. So we know JH is 3.5, and then we don't know JK, so I'm going to put an X there. From there, we're going to create a proportion. And we're going to compare JK to FG because those are the corresponding sides. So again, JK and FG, they correspond with each other. They're basically the same side in those triangles, even though the triangles are different sizes. So JK from the small triangle to the big triangle FG is equal to, and then we're going to compare it to this side JH. And then for the larger triangle, FE. Okay, so this is essentially how we're going to set up our proportion. In just a moment, we'll put the numbers in and then we'll solve the proportion. So JK was our unknown. We're going to put an X for the JK. FG was this top one, the same one that corresponded with JK, that was 21. And then JH was 3.5. FE from the larger triangle that corresponded to the JH is 10.5. Now we have a proportion that we can solve to find the missing angle X. When we solve proportions, we cross multiply or we take cross products. This is going to be 10.5 times X equals 21 times 3.5, which is 73.5. And then we have a one-step equation here. In order to solve this one-step equation, we're going to do the opposite of what's taking place here. This is 10.5 times X. So we're going to divide by 10.5 on both sides of the equation. And we end up with X is equal to 7. So this missing side length JK is 7, right? And so there's a proportional relationship between these two triangles, right? JK is 7, and if we multiply 7 times 3, we get 21. If we look at JH, the relationship's proportional. If I multiply 3.5 times 3, I would get 10.5. I'm going to allow you guys, pause the video, take a second to work on this problem right here. So again, the very first step is you have to figure out how the shapes are corresponding, which angles are corresponding. Then I'm going to take the smaller shape and draw it inside of the larger shape. One thing to note is that the angles in shapes usually go in alphabetical order, right? So this is going S, T, U, V. Over here it's going O, P, Q, N. O, P, Q, N. So this is actually a bad example because this doesn't go in alphabetical order. But I can see if I turn this shape to match so that all the sides and all the angles are corresponding, then I can see this is angle O, this is angle P, this is angle Q, and this is angle N. I'm going to leave it there. I'm going to let you go ahead and solve that. So I set it up for you. Again, we're going to look at this next one, finding the missing side in each figure. So here it says, Mason is making a model of a sailboat he saw in a lake. What should be the height X on Mason's model? So here they already have it set up for us, but they kind of gave us a real world situation, a real world problem, and they want us to find the missing side here. What we can do is we can do the same thing that we did on the other side. We can take the smaller one and draw it inside the larger one, right? They didn't give us any letters like J, K, L or anything like that, but we can look and we can see which sides correspond by this right angle right here. There's a right angle, there's a right angle, right? So if I wanted to, and I would advise you to, I would take the larger one, 15 feet by 8 feet, and then I would draw the smaller one inside of it. X over 4 inches. Okay, so then we're going, I can create a proportion. Again, a proportion is 2 equal ratios. I'll take the side lengths from the big side. We'll go 15 feet to 8 feet. And then on the second one, I'm taking the same exact ratio, right? I'm going from, so first we went from this side to this side, and I'm going to use a highlighter to show you the sides that correspond with each other. So these two sides correspond with each other, or if you're looking at the triangles over here, those two correspond with each other. These two correspond with each other. All right, and so I'm going to color code this proportion that we're making as well. So 15 is going to go with the X, right? And then the 8 feet is going to go with the 4 inches. And then from there, we're just going to cross multiply, right? 15 times 4, 8 times X. 8 times X is going to be 8X equals 15 times 4, which is 60, right? So 8, divide both sides by 8. X is equal to 7.5. So this missing side length is 7.5 inches. So let's just review some things that we did here. We talked about our essential question being how can we apply proportional relationships to solve problems with geometry, meaning problems with shapes. We learned properties of similar figures. We said that in order for figures to be similar, they have to have congruent corresponding angles, and the ratios of the corresponding sides must be proportional. When we were finding the missing side length in two proportional or two similar figures, we took the smaller shape and we drew it inside the larger shape, and then we found the sides that correspond, we made proportions, and we solved the proportions. Really, that's it in a nutshell. I want you guys to solve this last problem on your own, and we will review this in class the following day.